Good afternoon, everybody in Ukraine and in the Netherlands. We are very happy that you joined this today webinar about soil, the Ukrainian soil, and about carbon credits. This is the second webinar organized by Stiyka Ukraina. And Stiyka Ukraina is a group of Dutch companies from the horticultural sector with the support of the Dutch government. And we try to continue and to increase humanitarian and business activities in the Ukrainian horticulture. We focus our activities mainly to vegetable, fruits and berry productions with the view to the accession of Ukraine to the European Union. In this way, we hope to give you, as Ukrainian growers, some information, and also on our training field near Kiev, we can show some practical growing of crops. When Ukraine will access the European Union, it will bring a lot of opportunities for the Ukrainian agriculture, but also for the countries in the European Union. Together, we can organize a more sustainable and hopefully carbon neutral agriculture and economy to prevent further climate change. And that there is a climate change we have seen in all heat records again last summer. So it's very worrying when we see that certain European members want to block agricultural products from Ukraine because that is one of the basics of the Ukrainian economy. And we have to try to convince those members of the advantages of accession of Ukraine to the European Union. For us, it is unbelievable struggle where you have to go through during these times, and we only can try to help and to support you. What cannot be exported, however, is soil. And Ukraine is famous and desired about its soil. And therefore, today, we have the honor that Dr. Sviatoslav Balyuk, Director of the National Scientific Institute of Soil and Agrochemistry, will show us the status of the Ukrainian soils. Then Dr. Ariane Reineveld from the International Eurofins will introduce us to the world of carbon fixed in the soil and why it is important for production, but also how that contributes to reduce climate change. When you have questions, then please put your question in the WhatsApp of the Zoom, and when the presentation is finished, we will try to answer the questions before we go to the next speaker. Dr. Balyuk, I invite you to present your presentation.
Дякую. Доброго дня, шановні колеги. Да, будь ласка. Добре.
Михаил, скажи, пожалуйста, еще раз всем, чтобы выбрали язык правильно и переключились, если кто-то нас не слышит. Михаил, слышишь нас?
I heard Dr. Balyuk in the English version.
То есть я могу начинать. Дякую. Доброго дня, шановні колеги.
Dear colleagues, I want to thank the organizers of the webinar for inviting me to this and the possibility to give a speech on this webinar. And my topic today is the land resources of the Ukraine, the current condition, evolution, ecology, and protection. There you can see the map of Ukraine, the portrait of Ukraine. This is the new digital map of Ukraine. What can we see specific here about the region? First of all, is zonal climate and soils. So you can see when the climate changes, the soils also change. Then you can see the diversity of the soils. It's more than 800 types of soils distinguished in Ukraine. And even within one plot, one field, the soils can be different. Then, next slide. This, you can see low production soils of Ukraine in the thousands of hectares. You can see that a lot of soils in Ukraine are the salted or too acid, or it's a womby soil. So these are sizes of less low production soils. And here is the map of spreading of the black soils through the Ukraine. And Ukraine is this country of the black soil. This is our brand. This is national treasure, which is under special protection from the government. Over 60% of the soils of Ukraine are black soil. This is about 9% of the total world bank of the black soils. And here's the national map. It is a part of the global black soil map. And with this, on the next slide, Ukraine is 6th in the world. That's according to FAO. That's the size of the black soils. So Ukraine has 34.2 million hectares of black soils. And then next is, this is the potential of the soils of Ukraine. This is from the natural fertility and effective fertility. Effective fertility with adding fertilizers. And then we have to come to these numbers. Only by natural fertility, Ukraine can produce 40 to 80 million tons of grains. And by effective fertility, which means implementing agricultural techniques, it can do up to 90 million tons of grain and even more. And then you can also see the comparison of the wheat yield. Ukraine, in average, harvesting 32.9. Germany is about 68. Germany 98. And the reason why we have lower yields than other countries, first of all, is the lack of moisture. We have 75–80% of the territory with a deficit of the water. Then second is a degradation of land and low resource supply. And when we're talking about the resource supply, that also includes the knowledge and the science. And here you can see the sources of the information which we have about our soils. First is we have materials of the large-scale soils investigation, which was carried out in 1960s, 1957, 1961. That was a very huge study about the soils. After that, it was never carried again in such scale. Of course, these are all dated data. They do not correspond to the real situation. Maybe 30% of this information is more or less actual. On here, you can see, for example, the map in 1961, where was this large-scale study of the soils, and the modern study. So you can see these are two different maps of the soil. So we think that every farmer, every land user should have the updated modern map of his land, because that will help him to assess his possibilities and to choose the right crops for growing and to choose the right actions to do to improve the soil. Next, the source of information is the state cadastre of land, which also was originally based on this large-scale study, but also every 5 years there is agrochemical study of the soils when the agrochemistry of the soil has been studied. So this cadastre has been updated with this data every 5 years, because the farmers get every 5 years the new agrochemical certificate of the soil. Also, we have the data about the improved soil which needs irrigation, or the salty soil. They have been studied, and and this data has been also put into the system. And there is also some data from the universities and institutes. There's a general database which is also been updated by the information from the institutions like agricultural universities and so on. So there is a general database which has been updated every now and again. Also, in Ukraine, there is 89 long-term study stations have been registered, which these are the scientific stations which carry out long-term study or tests in agriculture. And just to summarize this, about the sources of the information about the soils of Ukraine. So this basically, it's rather informational and quite puzzled data. So we don't have like one solid, complete database about all soils in Ukraine. And here in our institute, we are trying to accumulate and analyze what we have, and then to put it kind of like it together to make it one informational system which would be available for the land users. And what are our tasks for the nearest future? First of all, is to do the second large-scale soil study using the on-land study, also some satellites scanning of the soil. We think we have to combine agrochemical tests with the satellite study and with the on-land survey of the soils. Second, we have to update or reform the way the soils have been monitored. So we have to take the system from the European Union. And the third one, also about the research stations, we also have to update information about them and combine them together. About the global transformation, evolution of the soils, we separate three basic directions. First is gradational vector, because the lands are being approved. The land is so we have to have three vectors. One is degradation vector, so we have to study which soils have been degraded. Another one is which soils have been improved, and quasi-vector is the vector which soils have been more or less having balance, so there's not so much change in it. Now, and the next slide is the degradation of the soils in more details. You see, worldwide, it's about 2 billion hectares are being degraded or being deteriorated. And we can separate like water erosion, wind erosion, chemical degradation, and physical degradation. And you can see in percents worldwide. And here you can see what happens in Ukraine with the degradation of land. We separate 18 different types. We distinguish 18 different types of soil degradations. The highest, of course, is the organic matter loss or humus loss. Then overcompacting, slacking, water erosion, acidifying, pollution with the radioactive elements, wind erosion. We can see that because of the climate change, the zones, growing zones, are also being changed. They're shifted to more desertification is taking place. So it's like 14 million hectares have been degraded. That's before the war. And the damage which have been caused by reducing the soil fertility is like 300 billions of hryvnias. And this slide is what we calculated, the loss of the soil fertility due to degradation process. So all kind of degradation process have been here presented. So with the low soil fertility loss, like between around 10-15%. We consider it, so low degradation is up to 20%, middle degradation is 35-55% fertility loss, and over 50% fertility loss, that's a high degradation of the land. And this is the dynamics of the humus content in the black soils of Ukraine. You can see 3 stages. First stage, that was through 80 years. That was 22% loss of humus. Then a low deficit balance, that was between 1960 and 2000. We lost about 10%. And now we have 2 ways of development. We either stabilize this project and stabilize the humus, or if we continue the way we did in the past years, we'll continue losing humus in the soil. Next slide. This is agrochemical certification of the soil, which confirms actually the previous graph. So for the 130 years, over the period of 130 years, we lost about 25% of humus in the soil. And this process continues. So what are the reasons of the soil degradation? When you look at the humus, for example, so here's the map of the carbon deposit in the world, and this is the national map of the carbon deposit of Ukraine. It is made by the FAO methodology. We calculated what is the deposit of the carbon in Ukraine. The reasons why there is a degradation of the soil. It's an optimal ratio of the land plots. So not enough informational support, lack of governmental programs, and lack of the governmental management of the soil. And here is the influence of the war for the soil, because the war destroys also the soil in Ukraine. And we can distinguish these ways of the damages, like military degradation causes mechanical damage of the soil. So basically the soil has been mixed up mechanically to the deeper horizons. Erosion takes place. Then there is physical damage to the soil. So soil is overcompacted, it loses its structure because of the heavy machinery, for example. Chemical, it's pollution with the chemicals like heavy metals, and here I have to mention that we face the problem of that our labs are not equipped well enough to distinguish all the chemical pollutants. Then there is the physical chemical pollution. It's about COC complex of the soil, and biological. We are losing biological life and development of the pathogens in the soil. And of course, other way of pollution is actually a lot of waste is getting into the soil. Here is the influence of the war to the soils. You can see it by regions of Ukraine. And we have these maps actually by regions, by district, and actually by every village. What was the influence of the Russian invasion? And I can tell you, dear colleagues, that the profile of black soil has been formed over the period of 10,000 years, and we can destroy it in a few minutes. The losses due to the military damage of the soil.
$15 миллиардов долларов.
The loss is $15 billion. That's due to the Russian invasion. And the next slide. These are photos and examples of the damage by the war, also to the soil. And there was international conference dedicated to this subject. It took place in 20th of October 2022. Materials are available online, and we made a resolution which has been submitted to the ministries and the Verkhovna Rada of Ukraine with the results. But we are facing a new challenge. That's a blowing of Kakhovka Dam. This is the ecological crime, ecocide, which was done. More than 3 million hectares have been damaged. And our government is preparing the project of recovery of this dam, and we are facing such things that a lot of erosion is taking place, solidification taking place, pollution taking a lot of place also with the waste, with the common waste. And National Academy of Ukraine Science of Ukraine is preparing the ways of recovery of this, so the ways to recover this solution. So we have to sow grasses, we have to conservate some soils now to recover them. So we have to sow some perennial grasses and leave it for a while to recover. And here is the protection of the soils. And I would like to talk about the land fund of Ukraine. We, dear colleagues, are having these specifications. We have very high level of agricultural use of the land. Also, a lot of land is been plown. So 54% of the soil is being plown. That's 80% of the agricultural land. By FAO, it's recommended that this number should be reduced. So plowing land and not plowing land should be 1-to-1, and we have it much higher. And this causes a lot of problems to regulate the soil. We think that the plowing land should be reduced by 5-6 million of hectares. Some institutes call even 8 to 10 million of hectares should be taken out of the plow land. And also the management system of the soil protection system includes the legal support. Also, there should be a system of actions approved which have to be taken. Here is the legal support of the soil protection. We are working for a long time about the law about the soil and recovery of the soil. But unfortunately,
Вот на этом я буду говорить. Значит, мы работаем над проектом закона.
Work on the project of the law about soils and their fertility. So we want that there would be a legal status for the soils. So there would be a special law about it. Because now the soil has been considered as a means of the production. So we want the status of this thing would have been changed in Ukraine. So there was a law. We want to introduce a law about the soils and their protection. Then we are standing on the position of that there should be also a law about monitoring of the lands. so that the lands would be monitored in time and in the space. And also we think that there should be a special service for land protection should be created in this country, in Ukraine. I know that Roosevelt have signed in 1960s about the special service, state service for soil protection, and this state service for land protection is responsible in America for the soil. Something like that should be done in Ukraine. And here is about the regulations about the law. There is a standardization committee in our institute, which is actually producing the standards, making the standards and methods of evaluation of the soil and soil improvement methods. So the main task, what we need now as a regulatory documents are, first of all, regulations about pressure on soil, which can be put. So agricultural production should be actually normed by the law. We also want to harmonize it with international approaches. And we also have to have ecological limitations of the land use, for the land use. And these are technological aspects of the soil protection. So we specify here 6 priorities. First is optimizing organic matter in the soil and humus. So this is achieved by crop rotation, by organic fertilizers application, and all different sources of the carbon and organic matter. And optimizing in the soils of the available elements. Here we say that we have to limit and scientifically organize the use of fertilizers and organic fertilizers and chemical fertilizers and crop protection. So all this, then crop protection from erosions and also other types of degradations. This is the complex of the anti-erosion measures like conservation of the land, maybe taken out of the arable production, soils which have been too much damaged, too much erosion is there. Then improvement of the sour and alkaline soils. That's about 10 million hectares of Ukraine are either too acid, too low pH, or too alkaline, and they have to be improved. So, for example, in the acid soils, you can apply lime to improve it. And alkaline soils, we have about 2 million hectares of these with a very high pH. They are very basic. So you have to apply gypsum there, for example, to improve. There is deep flowing when you take the carbonates from the deeper layers of the soil. And then you can improve the soil, and when you count it to the yield of the grains, for example, by 50%. And then protection the land from the pollution, also from compaction, from over watering. The Kakhovka dam, when it was destroyed, over 1 million of irrigated soils or land plots have been destroyed. And the south of Ukraine, where the Kakhovka dam was, this area without irrigation cannot continue as agricultural production. So it will take a long time now to recover the soils and the irrigation systems which were built there. So the reconstruction has to take place there. So these are the main approaches to the land protection measures. And we say that in Ukraine, at this moment, there's actively been discussed the solutions for these problems, which I have want to highlight. First of all, is the legislational improvements. So the laws and the norms have to be actually updated and developed, because we are the country with the unique soils. We still do not have a state program for the state program for the soil protection. So the government have to develop the program for the soil protection. Second is we have to create and develop this system of monitoring of the soils, which you cannot measure. We have to be able to measure what we're talking about. We have to renew our soil maps. We have to carry out the global Ukrainian soil study. And we hope that with this European integration process, when they have been activated, this will also stimulate these developments in Ukraine, so that we can become to a more European level of this matter. In this matter, Ukraine has very huge potential in agriculture, and we are sure that our soils, our black soils, is the locomotive which will bring up the Ukrainian economy from the deep crisis. Thank you for your attention. I'm trying to be in time. Thank you.
Yes, thank you very much, Mr. Balyuk. I have a question. Do the farmers realize themselves that the soil is deteriorating, and what do they do themselves about it?
В основном своем они это знают и усведомляют.
I think in the vast majority they realize it. But of course, the propaganda and popularization of this knowledge should be spread. I cannot say that our farmers know about this problem. Know about this problem enough. I can tell you one secret. I took a place in one round table about the land market, and there was the conclusion that okay, land market is successful, but in 2 hours they never discussed the soil quality or the soil protection. So through this, so they were discussing the land market, but not talking at all about protection of the soil. But we think the soil protection should be #1 at any reforms, because the farmers should first of all think about the quality of the land and what will he give to inherit to his ancestors in the future.
Yes, I see. And yeah, so does the what kind of influence does it have that the animal production has declined after independence of Ukraine?
Дякую, дуже такое слушне запитання.
Yes, that's a very good point, Frederick. In 1990, Ukraine had 27 million tons of manure have been produced by the animal farming. That was a side effect of the cattle farming. Now we could apply 7 to 8 tons per hectare of organic fertilizers. Now we reduce so much that we can apply no more than 0.1, 0.2 tons per hectare. And of course, that's reducing the amount of organic matter in the soil. I showed the graphic how it's reducing. And Ukraine have joined the convention about reducing the desertification of the soil. So Ukraine joined this world initiative, and we are seeking now for the organic matter or carbon sources. So which can be also, of course, the manure, it can be residues of the plants, it can be sapella, it can be different sources, but this is a big problem. We have to reach at least 8 tons per hectare of organic matter. Then we kind of balance it, but for the moment we don't have these sources of organic matter.
Okay, all right. Thank you very much, Dr. Balyuk. It was impressive to see also what kind of damage was caused by the war at the last years. And well, that you also have a lot of information about what was already a bit degrading before the war. So yes, we are also struggling with issues about organic matter and also about carbon fixation. And that's why I like to give the word to the next speaker, and that is Dr. Arjan Reineveld.
Yes. Thank you, Frederik, for the opportunity to give a presentation. My name is Arjan Reineveld, and I would like to give a presentation about soil carbon, about the organic matter, and about the carbon content, and why it is important for several reasons. I was impressed with the first presentation. There are a lot of things which are also very important for the topic carbon, which I will be discussing. And I also understood that there is a lot of degradation, which is of course exactly the opposite of what we all would like to see. So I will be talking about soil, and if we want to know about the soil health, about the soil fertility, we first need to take a soil sample. And why do we take that soil sample? Well, we take the soil sample to get grip, to get more insight in the soil status, in the soil health. And if you've got a higher soil health, if you've got a higher soil fertility, it is easier to obtain higher yields. I saw in the first presentation about the winter wheat yields. If you've got but it is for every crop. If you have a higher soil fertility, it's easier to get a higher production. And of course, soil fertility, soil health also relate to quality of products, taste, shelf life. However, this is not all. So soil health is important for production, but it's also important for some other things. There are, of course, a lot of worries in your country, that's all on our news every day. But there's also other things in the world which are worrying, and that's one of the things is that there are more and more people, and they need food. But all those people are also causing problems. The climate changes, and because the climate changes, we've got very intensive rainfalls. We've got sometimes very intensive fires, and there's a lot of pollution because of there are so much industry, so many people asking so much of the planet. And one of the other things which also cause a lot of problems is sometimes drought, very dry situations. Of course, limiting production, among others. So when you look at all those problems, they are in every country, and that's why the United Nations said we need to make a plan. So the countries together, the United Nations said we need to make a plan, the best plan to create a better world, and they created the Sustainable Development Goals. 17 goals, which we are all aiming for. And that includes a lot of things, but 7 out of these 17 sustainable development goals are more or less directly related to soil health. Among others, zero hunger, of course, because that's the food production, but also clean water relates to soil health. And number 14 of those sustainable development goals. Number 14 is the 13 is the climate action or beat climate change, and that relates a lot to soil as well, as I will explain in more detail further on. So a lot of things are related to soil health, and in short, you can say that if soil health is better and improved soil health, a higher soil health will also have a higher contribution to the sustainable development goals. But then I'm talking about soil health. What is soil health? When we look at soil health, and that's what was also mentioned in the first presentation, when you look at soil health, you can look at it as several aspects. It's the physical soil health, which means the soil texture, clay, silt, sand, calcium carbonate, cation exchange complex, physical soil health. And then we've got the biological part, and there's a lot of soil life in every teaspoon. There's more soil life than there are people on Earth, and there are bacteria, fungi, nematodes, protozoa, and if there wouldn't be an active soil life, then the soil would not mineralize, for example. There will be no nitrogen or sulfur supply, for example. So you need an active soil life. And then there's the chemical soil health, which of course is the main nutrients and the micronutrients, nitrogen, phosphorus, potassium, calcium, magnesium, but also micronutrients like bore or manganese. That's something you don't want. It's the contaminants like heavy metals, for example. And in the middle, and that is much what I'm going to talk, a large part of what I'm going to talk about is the carbon content. So the soil organic carbon content is related to the physical soil health, to the biological soil health, to the chemical soil health, and to the contaminants. It is kind of the center of all. And you could say that you, with your black soils, which I learned at school a long time ago already, Ukraine, black soils are the best soils. But then the organic matter content of those soils is of big importance. And I will be talking. I'm talking about organic matter sometimes and organic carbon. Perhaps it's important to mention that it's almost the same. But when you talk about organic matter, that's the organic material, and about 50% of the organic matter is organic carbon. So about 50% of organic matter is organic carbon. And why is that organic matter, organic carbon, important in the soil? It is important because a lot of things are related to that organic carbon content, organic matter content. For example, if you've got a little bit higher organic matter content, heavy textured, heavy clayey soils will be easier to work. So the workability will increase. You've got a higher organic matter content. When you've got a little higher organic matter content or improved organic matter content, then the soils will be less drought sensitive, and they will also, for example, be able to when it rains very intensively and you've got a high organic matter content of the soil, those rains will be absorbed much better than if you've got a lower or decreased organic matter content. But it's also food for soil life, so to keep your soil active. And if you have organic matter in the soil and you've got a soil life, that combination will also cause for mineralization of nitrogen and sulfur, so supplying nutrients to your crop. And also very important, organic matter binds nutrients like calcium and potassium and magnesium. And that means that if you've got, if you fertilize and your organic matter has become lower, the risk that calcium and potassium and magnesium will leach becomes also higher. If you've got more organic matter, that will easily bind calcium and potassium and magnesium. So it has also to do with the efficiency of fertilization. But it's more, and that's what I will discuss. On the Earth, we see that normally there's radiation from the sun, and that radiation will also leave the Earth, like in this picture. Since we've got greenhouse gases more and more, and that includes carbon dioxide and methane, the Earth is rewarmed and rewarmed and rewarmed again by those greenhouse gases, and that makes the Earth warmer. Why do we have all that carbon dioxide, for example? Well, that's because we are with a lot of people, industry, cars, fires. More and more CO2 is in the atmosphere. And you can already see in this figure that there's also CO2 in the soil, actually as organic material. And that is something which I will show in this figure as well. In the forest, in the biomass, in arable crops, in vegetable crops, in grasslands, there's CO2 stored, 360 billion worldwide. And then in the atmosphere, there's also CO2.
Sorry, can you say it again, the first part about this forest and things, because I have to get.
Yeah, of course. When we look at the CO2 or carbon, perhaps it's important to mention that if you go from organic carbon to CO2, you multiply by 3.67. I mean, most farmers know that if you have got phosphorus and you multiply that by 2.21991, you can have P2O5. So P to phosphorus to P2O5 is multiplying by 2.2 and something. If you go from carbon to CO2, you multiply carbon times 3.67. So it is a way of expressing it. And then when you look at carbon or CO2, you can see that there's carbon in biomass, in forests, in grasslands, in maize, in vegetables, in every crop, in every nature, in every biomass. And there's also carbon, CO2 in the atmosphere, of course, and you don't want that because that will increase climate change. So you want less CO2 in the atmosphere. And there's also, and then you can see that's a lot of CO2 carbon in the soil.
And this 360, 800, and 4,000, that's kilogram, tons, megatons, which units is it?
Billion ton of carbon in the world. So the main message of this figure is that most of the CO2 is stored in soils already. So already now, most of the CO2 is stored in soils. And of course, we want to keep it there because if there's degradation, like the first presenter showed very nicely, if there's degradation, decrease of carbon in the soil, it will go up in the air and it will increase climate change. So we want to maintain the amount of CO2 in the soil. Actually, it would be better to improve it even, because if there's more CO2 in the soil, then there's less in the atmosphere. So this one is very important. There is already a lot of carbon in the soil, and it should be more. And that's what is stated in the Paris Agreement in 2015. It was said at the United Nations meeting. We, the world, should all try to increase, so not decrease or degradation, but increase the organic matter content of the soil by 0.4%. So instead of the degradation, which you have in the Ukraine and in a lot of places in the world, we need to increase the amount of CO2 in the soil to make sure that we beat climate change, at least try to beat it as far as good as possible. So farmers, growers, agriculture in general is very important. They are the owners of the largest source of CO2 in the world. So farmers are, I mean, it's most important that all that organic material stays in the soil or that it even increases. But if you, and that's also something which I heard from the last speaker, if you can't, we should measure and monitor that. That would be, otherwise you don't know what's happening, if it's increasing or decreasing, or in which regions it is increasing or decreasing. So that's why we created a soil test and a soil test report, especially focused on this aspect to measure and monitor soil carbon status. And that soil carbon check report, which is based on the soil test, and then we measure a lot of things. That includes, that tries to answer 4 questions. And those questions are: how much carbon is in the soil? What is the quality? Is it stable or will it disappear very soon? How can I improve my carbon status? So it's the balance, organic carbon balance. And 4, how is it doing over time? And the soil carbon check has been introduced in the recent last year, in, for example, Finland. In Finland, it has become part of legislation. So a farmer needs to prove and show that his carbon status remains the same or improves. And then he gets rewarded. Rewarding farmers when organic matter is stable or increases is also something which bigger companies start with. Crop protection companies like Bayer are working on it. The milk industry, Arla, but also companies in the potato industry, they all want to show to the government or to the people, look, we are producing crops, milk, vegetables, and at the same time we are maintaining organic matter at the same level or improving. And like I said, the farmer, the grower is very important, because when we face all these problems in the world, more and more carbon in the soil will help to tackle at least this kind of problems. It has been translated to Chinese, Vietnamese, and to France. It's introduced there. So it's already introduced in many countries. And I think that is a nice thing, because a lot of companies are international, working not only in one country. So if they have the same product, the same results everywhere, it is also good, for example, for the European Union, like you mentioned before, Professor. It is also important that you can compare the results within Europe, for example. Well, this is what you can also see on the report. If it's changing on the horizontal axis, the years, on the vertical axis, the organic carbon content. And in this example, you can see that it increases slightly, but in this example also significantly over the years. And the increase, it's written in this figure, but it's not translated, but then there's written the increase has been 3.1 ton carbon dioxide per hectare per year. So that is the increase over those 4 years, the average per year. And that accounts to 3 carbon credits. So there's the system which you want to, when you prove and claim that you've got that you have captured CO2, that's also related to credits. And in some countries, some governments, some companies already pay for that. So increasing carbon content will also be something which you are paid for. And for example, I asked yesterday in the Netherlands at this moment, per hectare about 120, 130 euros is paid per carbon credit per hectare. Well, there's a lot of calculations. I think I will skip this one. Perhaps it's a little bit making things overcomplicated. But in the end, what I was trying to show here is that the organic carbon is recalculated to CO2. And the CO2 is then recalculated to carbon credits. And that's what's written here. So you've got the organic carbon content. You can recalculate that to suit CO2 per hectare, and the CO2 per hectare or per air other unit is then recalculated to carbon credits. And those carbon credits can be, and that's, like I said, promoted by some bigger companies and governments already. They are worth money. We wrote everything, the system we wrote down in a scientific article, which everyone who is interested can have a look at. And then the question, of course, arises at the end of my presentation, towards the end of my presentation, can we improve? Is it possible to improve that 0.4% organic carbon? Because, well, Professor was mentioning there's degradation, and it should be the other way around. It should be an increase of organic matter. And then, is it already happening worldwide? An increase in carbon content of the soil. This is an example of Brittany in France. In 1980, left in the upper, in the top of the presentation, left upper part. The orange part is low in organic material. So this is Brittany in France as an example. Orange is low in organic matter in the 1980s. You can see that the amount of area, the area where the organic carbon, organic matter content is low in the at the end of this of the 1990s, that increased So there was a decrease in organic matter content. And when you look at the recent results, it has become even lower. Everything which is light blue or blue is a decrease. So you can see that there's even up until now a decrease in organic carbon is continuing. Also in the United States, in the United Kingdom, in England and in Wales. But when you look at research, you can see that you will be finding out that there is a decrease in Belgium, in France, in Austria, in Norway, in Finland, in Germany, in Spain, and in the Netherlands. It's almost I think in Czech Republic as well, but then almost the only country where it kind of remains at the same level. And that, of course, relates at least partly.
Say it again. There is the only one country where it's not been increased. Which country is that?
Yeah, in the Netherlands and the Czech Republic. The organic matter content stays the same. So in most countries it decreases, and in the Netherlands and I think also in the Czech Republic it remains the same. And why is that? Well, it partly relates to what was also referred by Professor to the input of organic material. Of course, when there's enough manure, for example, it is easier, of course, to maintain or even improve organic matter level. So it doesn't look good, perhaps, because when you look at all those that research, there's a lot of decline instead of increase. Still, there has been a lot of focus on improving organic carbon content in the last, well, 5 or 10 years. Everybody's talking about soil health. Everybody's talking about improving soil health. A lot of companies are working on it. And then when you look at recent results, we had some trials at practical farms. And in this example, we have 9 arable farms, and we had soil tests, and we had fields. And then we looked at the input of organic material, of manure, straw remains, to show the remains of straw, for example, in an arable rotation, compost, type of crops in general, all those things, green manuring, so intercropping sometimes, all those things had an effect on the input and the output of organic matter. And we saw in this practical farms that even though there were some fields which were declining, on average, the increase was higher than the decrease. When the farmer was able to have enough of organic matter, he was also able to increase his or her organic carbon content of the soil and earning the carbon credits. So perhaps I'm going very fast, and perhaps it's new and I should go into more detail. But because it's also meant as an introduction, I want to summarize already. The most important thing perhaps is to realize that when we look at the climate change, that soils play a very important role. Most of the carbon dioxide in the world is stored not in the ocean, not in forests, not in the air, but it's stored in the soil. And if we all would be able to increase that amount, which is already high in the soil, we would contribute in beating climate change. And like I said, farmers are very important for that. They hold the key. And again, like the first speaker said, if you don't measure it, if you don't monitor it, you don't know it. So with the soil carbon check, you can measure and monitor the changes and the current status. And like I said, increasing is not easy. We saw a decline in many regions, many countries. But on the other hand, if farmers really are able to have enough input of animal manure, of compost, of green manuring, of perhaps straw, the remains of straw, then, or other crop residues, then the input is higher than the output and the organic carbon content increases. Well, that was it. I work at Eurofins, perhaps you have seen that. and we are working in a lot of European countries. And I would very much like to be in your country again, on the better conditions, circumstances for you all. And of course, we also look at the total agro cycle, not only soil, because all the other things are, of course, also important. And I want to thank you very much for your attention and again for the invitation. Thank you.
Thank you very much, Arjan. We have one question, and that is how often should the farmer take soil samples?
Yeah, well, today I only showed a soil sample which looked at carbon, and carbon only changes very slowly throughout the years. So a soil test for carbon doesn't need to be that often. But if you also look at test,
but what is not that often? How often should you take?
Yeah, once in 3 or 4 years. But if you look at nitrogen, for example, or sulfur, it changes very soon. And for some crops, which are very sensitive for too much or too little nitrogen or sulfur, you should take a sample, well, every year. So it depends a little bit on which crop and which nutrients. Normally, a normal soil test can be every 4 years. But when you want to focus on quality, for example, of some vegetable products, sometimes that's what we see all the time. Sometimes for vegetable production, it is done every year.
Okay, thank you very much. I have also a question, Arjan. The increase of this organic matter, is it? It's more easy on more acid soils maybe than on basic soils or alkaline soils. So if there would be a system to pay farmers somehow, then it's maybe easier for some farmers on different soils. Is that so? Or can you say something about it?
Yeah, well, I have to refer to the first speaker again. It can be very different on every soil because on acid soils, for example.
Please not so quickly because I don't catch up with the translation.
Sorry.
Just speak a little bit slow.
Yeah. Sorry. On acid soils, for example, the availability of contaminants like aluminum or too much of cadmium, for example, so aluminum of cadmium can be very high, and that will decrease root development. And because of the decreased root development, the organic matter.
Can you say it again? What is decreased root development? Once again.
The question was, is it perhaps easier on more acid soils to build up organic matter? That's correct, Fredrik.
Yes, right. So that's
And
right.
then, yeah, and then my answer would be that on some acid soils, there are also a lot of elements which can decrease root development, like aluminum concentration or cadmium concentration. And with the decrease of root development, there is no building up or very little building up of organic material. On other acid soils, there may be hardly any aluminum or cadmium, and in that situation, organic matter is built up very nicely. So even within some kind of the same category of soils, acid, there's a big range in how the soil organic matter is built up. And the same accounts for the more with soils with a high pH. Even there, the soil nutrients can be very different. And in the end, when you will want to build up a high or good or an improved organic matter content, you want all the nutrients to be in the right order. You don't want anything to be the weakest link.
Okay, thank you very much. So if I can conclude a bit, to increase the organic soil, we have less drought, less erosion, and better nutrient accessibility, I would say.
Yes.
And so farmers can get a higher yield, right? And but if they increase this organic matter, they can even maybe get in the future some kind of money, maybe from the government or whatever, to also yeah, maybe get a higher price for that product or so. That would be nice, if that would be so, because then also the consumer pays maybe a bit for this increase of organic matter. I like to thank very much Dr. Balyuk for his nice overview of the Ukrainian soils throughout the years, and to get a good impression. And so we hope that, that we can do something to stop this erosion, not only in Ukraine, but of course you see also in European Union, there are many countries who struggle with the same problem. And Arjan, I like to thank you as well for the nice overview of the carbon credits, and especially organic matter in the soil, how you can translate it to this carbon credits. Thank you very much. The next webinar will be, I think, in 2 weeks. Then we will announce it through Facebook and other social media. Thank you very much, and I wish you a nice evening. Thank you.
Дякую.